Welcome to lecture number 7. We are studying probability and statistics, and in this lecture we'll study how to draw a line plot. Line plot is for quantitative data. It is drawn for quantitative data. It's very important. And it is used when the data is recorded over equally spaced intervals that are most of the times they are time intervals. That if we record data versus time, the data recorded versus time in equally spaced intervals is also called time series data. So the line plot or line chart is drawn for time series data. The example is that this is the projected number of citizens that will be 85 years or older in millions in year 2030, 2040, 2050 and 2060. These are 9.6 million, 15.4 million, 20.9 and 26.5 million in a country. So these are the projected number of people with age 85 years or more. So how would you plot it? We'll plot the experimental units on x-axis and the values of the variable on y-axis. So here we have only one variable versus these experimental units. Experimental units are 2030, 2040, 2050 and 2060, and these are the values of variables. So we plot values of the variable on y-axis, and we see that in this case it is a linear trend. So mainly this type of graphs, they are used to discover patterns or trends in data. This means that if we want to know the approximate number of people with 85 years age or more in maybe in year 2070, so how would you guess that? You just continue this line in the same way as it has been previously from 2030 to 2060. So we'll extend this line up to 2070, and this is the projected number of people with 85 years or more in year 2070 in this country. So this type of graph is mainly used to discover patterns or trends in a given data. Right. The other kind of plots that we will study in this lecture, they are dot plots. Why they are called dot? Because we place a dot versus each data point, and they are used to discover distribution of data. If you are given data and you want to know that how many number of, for example, we have this data, this raw data, and you want to know how many number of 2 are here, I mean the frequency, how many number of 6 are there, how many number of 3 are there. So this is how we can guess about the distribution of data. That in this example, how do you plot it? We'll write it as 1. This is not 1, 0. This is 0, 2, 4, 6, 8 and 10, and we'll navigate through this data. We'll come across the first data point 2 and we'll put a dot here, and the next data point is 6, we'll put a dot here. The next data point is 9, we'll put a dot here. The next is 3, we'll put a dot here between 2 and 4. The next is 7, we'll put a dot here, and then we have again come across a 6. This means we have 2 6, so we'll put another dot on top of the dot we have already plotted. So this is how we plot it. So this gives us a distribution that we have number 6 appearing the most number of times in this data. So this is how we can have a guess about the distribution. We'll talk more about probability distributions in our upcoming lectures. and we'll use such graphs like this and other type of graphs like histograms in our upcoming lectures. Right, there is another example of plotting a dot plot. Suppose we are given this data of CGPA for 2K18 batch, maybe for section A. Suppose this is the data for 2K18 BMET section A. So the first guy has obtained a CGPA equal to 3.3, the next guy 3.5, and so on. So how would you plot a dot plot for this given data? So we will draw a horizontal line first, and then we'll look at 3.3. Where is 3.3? This is 3, this is 3.25, this is 3.3. So we'll put a dot here, 3.3. The first dot will be placed here, and then the next data point is 3.5. So then we will put a dot here. The next data point is 2.9. We'll put a dot here. Oh, sorry. We'll put a dot here. A dot at 2.9. Then we have 3.3. Where is 3.3? This one, 3.3. So we'll put a dot here. So if this is the second example, this is the second time we have come across a 3.3. So we'll have another dot on top of the dot we already have. Initially we have this dot, and then we have again encountered an example 3.3. Encountered another data point equal to 3.3. So we'll put a dot on top of this dot, and if we again come across a 3.3, for example this one, we will put a dot here. So this gives us a distribution, a kind of idea about the distribution that most of the students in the class, they are between 3 and maybe 3.3. So majority of the class is between 2.9 and 3.3. So this gives us an idea about the shape of the envelope of this data, and we'll talk more about the shapes or the envelopes and probability distributions in our upcoming lecture. But this is the plot that gives us a very good idea about the distribution or the placement of data in given draw, the placement of data or the distribution of data in a given set of raw data. So mainly this is plotted over raw data. Right. So that's all about dot plots and line chart or line plots. So we'll keep on studying more about different kinds of plots in this chapter and in our upcoming lectures. Thank you.